Welcome back to the NMR Challenges series. In the previous video, I provided this NMR challenge for you, and today we are going to explain the solution step by step. If you have already solved it, then you can match your answer by the end of this video. So let's start today's NMR challenge.
So here is our fifth NMR challenge. We are going to determine the structure of this organic compound having molecular formula C6H8O2. So while determining the structure of this organic compound, we are going to follow all those steps which we learned in the last videos. So first we will calculate the index of hydrogen deficiency, then we will look 1H NMR, and after that we will look 13C APT NMR. Before solving this problem, we are going to revise all those steps which we are learning since beginning, and we will revise chemical shift value for 1H NMR and 13C carbon NMR as well. This is very important to keep revising because this practice will make you perfect. And here are those steps. So first step is calculating the index of hydrogen deficiency, which is also known as degree of unsaturation, and this is the formula. So this formula is 2 multiplied by number of carbon atoms plus 2 plus number of nitrogen atoms minus number of hydrogen atoms minus number of halogen atoms divided by 2. So the value gives number of pi bonds or rings, or it could be both. If this value is equal to 5 or greater than 5, then we can blindly say that it has one benzene ring, and this benzene ring will correspond to the 4 value because it has 3 pi bonds plus 1 ring. Then we will see 1H NMR, and as we said that number of signals is equal to the how many types of protons are there. Splitting patterns will give us information about the number of neighboring protons or substitution pattern on the benzene ring. So here is the splitting pattern formula, n plus 1, where n is equal to the number of adjacent protons which are equivalent. And for determining the substitution pattern on the benzene ring, we should also know the J coupling value. So we will learn when we will have those kind of problems. So here we are just focusing on the aliphatic types of compounds so far. And 1H NMR chemical shift values is also very important to understand shielding and de-shielding of the protons. As I told you, primary carbons, hydrogens coming in the shielded region from 1 ppm to 1.2 ppm. Secondary carbon hydrogens are slightly de-shielded as compared to the primary, and tertiary hydrogens are slightly more de-shielded from 1.4 ppm to 1.9 ppm. And we also learned that when methyl is attached to the ketone, then it comes from 2 ppm to 2.6 ppm, and it is quite similar value for methyl attached to the benzene ring such as in toluene. So it is also coming in the same region. Acetylene protons is slightly de-shielded as compared to the methyl attached to the aromatic rings. It comes from 2.5 to 3 ppm. This is very interesting value. When oxygen attached to the carbon, then hydrogens are coming around 3.5 to 4.5 ppm more often, and it could be higher also, but usually you will see in this range. And when it is attached to the nitrogen, then it can come from 3 to 4 ppm. We also learned that hydroxy and amines protons are acidic, therefore they can undergo exchange from one molecule to another molecule, therefore their values are not fixed, and it is coming from 1 to 5 ppm. The aromatic protons comes from 6 ppm to 8.5 ppm, sometimes overlap with the alkene protons. This depends on the nature of the alkenes. Aldehyde protons comes from 9.5 ppm to 10.5 ppm, but carboxylic protons always comes after 10 ppm to 13 ppm, and it is slightly broader signal. So we should remember these values because it is very important to determine the structure of the compounds. Then the third step is 13C APT NMR. So we will look 13C APT NMR, and we know that this NMR gives all kind of carbon signal, but in 13C depth NMR we don't see signal for quaternary carbon, the carbon which doesn't have any hydrogen. It also tells us how many types of carbons are present in a molecule. And we also learned that methane and methyl peaks are 180 degree opposite to quaternary carbon and methylene carbon. So in this spectra which we are going to show here, the quaternary carbon and CH2 signals coming in the upward direction, or we can say in a positive phase, and methane and methyl carbon are coming in the negative phase. But remember that when you are solving in MNOVA or any other software, then you can change it. You can change this phase by yourself, and then it could be opposite. But here the NMR which we are looking, in that case we are following this pattern because those NMRs are presented in this way. It is also important to remember some of the chemical shift values for carbon. So here are the some chemical shift value for the carbon. When it is primary, so it is coming up to 35 ppm. When it is secondary, it is slightly deshielded. Tertiary is coming maximum 55 ppm. When it is connected to the oxygen, then it comes from 50 to 70 ppm more often, but it could go to 90 ppm depending upon the structure. Acetylene carbon comes from 70 to 90 ppm, and benzene carbons comes from 110 to 170. These values for the functional groups is very important to remember. Ester comes from 165 to 175 ppm, but amides could be slightly lower than ester. It can be from 160 to 175 ppm. Carboxylic acid is slightly higher from 175 to 185 ppm. Aldehyde always coming in highly deshielded region from 190 to 200. Therefore, it is easy to distinguish between carbonyl carbon from ester or carboxylic acids. So after revising all those chemical shift values, now we are ready to take this challenge. So first we will calculate the index of hydrogen deficiency. So 2 multiplied by 6 plus 2 plus 0 nitrogen, 8 hydrogen, no halogen, so divided by 2. So 3 degree of unsaturation. So it could be all pi bonds or ring plus pi bonds. Now we will look at 1H NMR. So how many signals are there? Only one signal. This means there is only one type of proton. So let's say this is A type of proton, and this signal comes around 1.72 ppm. It is singlet and correspond to 8 hydrogens. So it means the neighboring n value is 0. This value indicates that all 8 hydrogens are equivalent. So this means that molecule is highly symmetrical. What else information we are getting from 1H NMR is that this value 2.72 indicates that there is a electron withdrawing group in the neighbor, because aliphatic carbons without any electron withdrawing group cannot come around 2.7. If you remember, when CH2 attached to the keto, then this hydrogen comes around 2.1 ppm, and when CH2 attached directly to the oxygen, then this hydrogen comes around 3.5 to 4.5 ppm. At this point we don't know what is in the neighbor. So now look at the carbon NMR. So from the carbon NMR there are two signals, one is this and another is this one. So it means it has two types of carbon. Signal at 2.08 ppm indicates that the compound have keto group. It could be aldehyde, but we didn't see aldehyde proton in the 1H NMR, and hence we can easily say that this is not aldehyde but it is keto group. So 1 unsaturation is attributed to this keto group. Now this signal at around 35 ppm is correspond to CH2 group, as we know that the upward signals belongs to CH2 or quaternary carbon. Since it is in deshielded region, so for sure it belongs to the CH2 group, and this one belongs to the keto group. So it means all the CH2 group are equivalent. So it means this molecule doesn't have CH or methyl group. So this molecule is highly symmetrical, and we have to understand that only 1 degree of unsaturation is going to keto group, and we have 2 oxygen atom. So I am thinking that maybe there is second keto group in the molecule. If the molecule has 2 keto group, then I am thinking to draw the symmetrical structure. If I try to make symmetrical structure like this and to put double bond for 3rd degree of unsaturation, because we have 3 degree of unsaturation, then here it will be 1 carbon, 1 2 3 4 5, then this. If you satisfy its valency, then it will be CH3, this will be CH3, this will be CH and CH. So there are 3, 3, 6, 8 hydrogens. But as we said that the compound doesn't have methyl or CH group, so therefore this structure is not possible. So I am thinking that this molecule has ring structure, and then we can say that this ring has 2 keto group. So 2 keto group for 2 degree of unsaturation and 1 ring, so total 3 degree of unsaturations is there. Now if I draw the plane of symmetry, then I see that this carbon and this carbon hydrogens are equivalent, A type, but this one and this one B type. So it will show you 2 types of hydrogens, but in the NMR we are seeing only 1 type of hydrogen, and hence this is not the correct structure of the compound. Now there is another possibility that maybe this keto group is present like this, then this compound have molecular symmetry, and then this will have A type of proton, this will be B type of proton, and then this will be C type of proton. So it has 3 types of proton. So this is also not possible because we need only 1 type of proton and 2 types of carbon. So let's look at the last possibility, which is like this, in which both keto group are 180 degree opposite. If you see this molecule has plane of symmetry, and this is A type of hydrogen, this is also A type of hydrogen, this is also same, this is also same because it has keto group in the neighboring. And if you see this molecule has further symmetry, therefore this compound has CH2, all CH2 are equivalent, and hence 8 hydrogens will show only 1 signal. Now look at the carbon. So this keto will show you signal at 208, and this will also coming at 208, and this carbon, CH2 carbon, is coming at around 35 ppm, and all will be at the same position. So it has 2 types of carbons. So unequivocally we can state that this is the correct structure for the given NMR data. Now here is the NMR challenge for you. This compound has molecular formula C6H4Br2, and if you look, this is also highly symmetrical molecule because you have only 1 signal in the NMR, and which is around aromatic region. So this is easy to solve. If you manage to solve, then don't hesitate to post your answer in the comment section, and I will disclose the solution in the next video. So don't forget to subscribe my channel. We will see you in the next video. Thank you very much. Take care. Bye bye.